If you're looking for one welder that you can use for pretty much any project, you want to stick around for this one.
We're taking an in-depth look at the HTP Revolution 2500. It's their new multi-process machine that can run AC TIG and DC TIG for all sorts of different materials. It can run standard short-circuit MIG as well as pulsed MIG, which is completely unique for multi-process. It can stick weld too, and it comes from the same heritage as their Invertig and ProPulse machines that have had such a good reputation over the last several years. I've been using it personally in my shop for the past 6 months, and so I can give a pretty good idea of some of the great things it can do, as well as some of the things I don't like about it.
Short of consumables, this machine includes everything that you need to get welding. They have a few different packages available on their website depending on what you want to do.
They really didn't skimp on the quality of the accessories. It's either a CK Worldwide or Heavy Hitters Torch, depending on your package, both of which with a Superflex cable. The foot pedal is well made and operates smoothly, and the leads are high quality, heavy gauge, and it's a really nice package. So it's all the stuff you'd upgrade to if you got something else and wanted to upgrade the accessories.
One question that I hear a lot about machines that have a lot of functionality built into them is whether it's going to be too complicated to operate or not. Well, something that I think they actually improved on a lot with this machine compared with some of their past models is having really good defaults and automatic settings, so you really don't have to mess with the settings unless you want to. Then they're available there for you to fine-tune things.
So to show you what I mean, I've reset this to the factory default, and I'm going to click through. This is all you need to do to be able to be set up in MIG welding. So select that I'm welding on steel, that I'm using mixed gas, that I'm using 030 wire or 0.8 millimeter, and then I'm ready to go. When I change my wire feed speed, it automatically adjusts the voltage for me. I can fine tune that if I want, and it gives me a reference thickness that I'll be able to weld. So we're set up. Let's go ahead and start running some different examples here. I have some 1/8 inch plates tacked up in a T-joint. I'm running pretty close to just a straight line here. I do make a slight amount of movement just to help time my progression, but in general, I like to keep it as smooth as possible. If you wanted to put more of a pattern in this, you might need to run lower settings than what they recommend. But for the way that I like to weld, I think the settings are spot on. They're really good on this one, especially for this 1/8 inch thick material here. We'll take a look at some of their other recommended settings here in a minute as we try a whole bunch of different thicknesses and types of material on all of the processes.
Now, I won't show you the navigation through the panel for every single weld that we're doing in this video, but they do have on their website a video owner's manual that walks through navigation on the panel for every function. So that's on their website. I actually made it for them. I'll link it in the description below so you can see every single setting and how you navigate through those right there.
So that 1/8 inch thick material was kind of a middle of the road thickness. I want to move down a little bit thinner. So I have some 16 gauge here, and I'm setting it up with an outside corner joint. And I'm going to weld along here, and in order to do that, I just trace the seam and read the puddle. Make sure that I don't run too far away from it, stay right up there on that leading edge without leaving it behind. And it lays in pretty thick, and it's running pretty smooth here on this lower setting. Now an 023 wire might be a little bit better, but this 030 works just fine, and I got some good penetration all the way through to be supportive if I were to grind that down. So it worked out well here in this case. Now I thought maybe I'll take this to an extreme. I got some razor blades to try out the TIG, but I thought maybe I could MIG weld them. So I turned the machine way down, and this is really pushing it with 030 wire, but it worked. And I was able to get through it largely because of that aluminum plate underneath. So I figured I'd try it up here in the air and see if I was able to do that. And well, you know, I was surprised how well it went. I must have slowed down there for a minute. It was close, but we have a lot of other things to look at. So let's move on to some thick material here on 1/4 inch. Now with this 1/4 inch, I've set the machine to its recommended settings, and one thing about this machine is the setting for thicker material actually has a much higher voltage than a lot of manufacturers use on that thickness. And this makes for a bit more of an intense arc, and at first I didn't really care for it. I thought, you know, I don't know about this, but honestly, when you think about it with short circuit MIG, the chance that you have of a lack of fusion defect, I think it may be a good thing. So let's dive into it a little bit more. The weld actually looks pretty good, and here when I check the size, it comes out right around a 1/4 inch, which is perhaps a little big for this depending on what you're doing. But I wanted to test it, and I realized quickly I'm not really set up for a brake test, so I went ahead and cross-sectioned it so that we could take a look, and you can see it did penetrate down there into the root, and that's with 030 wire and 7525 gas on 1/4 inch plate.
Now all that MIG welding was done with the short circuit transfer mode. I'm going to switch my gas cylinder over from 75% argon, 25% CO2 to 90% argon, 10% CO2. Now that gas mix can still run short circuit transfer, but it can also run spray transfer and pulsed MIG. Let's take a look at that.
I have this in MIG manual mode. I want to show you what spray transfer looks like. Now notice it can go up to 35 volts, which is a lot higher than a lot of machines, but I'm setting this up to do something a little non-conventional for this demonstration, and that's run spray transfer with 030 wire on 1/8 inch plate. Now notice how smooth it is, and there's no spatter at all whatsoever. So this is really nice compared to the MIG that we normally run. However, it's a really hot process and it can't really be used out of position. So another way besides the short circuit process that you can limit your heat input is by using pulsed MIG, and this has pulsed MIG available. And so notice there's no spatter here, it's just that nice spray arc, but you are able to limit that heat input by pulsing automatically, and you come out with something that's clean and spatter free. So that's a really nice feature to have built into this machine, and it works pretty well.
Beyond the solid wire that we've run so far, this machine also works really well with flux cord wire, both gas shielded and self-shielded. Now with self-shielded flux core, you typically need to switch your polarity to DC electrode negative, so the negative will be connected to your MIG gun. Now most machines you have to do this manually by moving some taps on the front or inside the panel, but here it actually does it for you, so when you select self-shielded flux core in the menus, it'll electronically change your polarity. One less thing to think about.
Now while I'm changing the wire out, I just thought it might be a good chance to take a look under the hood here. You can see that the spool brake there is a little more heavy duty than you typically see, and that's pretty important to be able to regulate your wire there so it doesn't free spool on you without overloading everything. That's a Swiss-made drive mechanism. It's the same one they use on some of their other machines, I believe. But it's a really good drive because the actual drive speed is extremely important, especially with pulsed MIG, to be able to have a steady, consistent drive. So it is a nice setup there inside, I think, under the hood. It is limited to just 8-inch spools, though. Now I'm setting this to flux core here, and I'll show you that it automatically changed to electrode negative here, so it's all set and ready to go. And so I'll try this out. You know, self-shielded flux core is not my favorite thing. You still get some spatter. It's just the nature of the process, and honestly this wire that I'm using is just some stuff I had laying around, and it isn't necessarily the best, but the result isn't too bad for the process that we're running. What I like a whole lot better, though, is gas-shielded flux core. A lot of people call it by its trade name dual shield. Gas-shielded flux core is really like welding on easy mode. I mean, look how smooth and clean that is. It works really well, and also because it has a tubular wire, you can actually get a little bit better penetration, and it provides really good properties. So there's a lot going for it. Now, if you look at this compared with the self-shielded flux core, it's just a lot more smooth and clean than that self-shielded flux core is. Now this is 035, or it's a smaller diameter gas-shielded flux core. In industrial settings, you'll often see it much larger, but this 035 gas-shielded flux core runs really well on this machine. I'm really happy with it, and it's a great tool to have in your belt. Largely because it uses the same shielding gas as short-circuit MIG, so you don't need another gas cylinder, just another spool of wire you can throw in when you want to have a lot of confidence and have welds with good properties, and they just look nice and smooth. I like it.
All right, well that's a lot of ways to stick steel together. How about MIG welding some aluminum? Now one of the challenges with aluminum MIG welding is feeding that soft wire. And a lot of people address this with a spool gun, and the Revolution can connect up to a spool gun and use that, but it also is able to use a gun that they specially set up to weld aluminum and feed it right out of the machine. Let's see how that works.
To really try this out, I wanted a wire that was hard to feed, so I picked 4043, which is a soft alloy, and 035, which is a small size. So that should make it a bit more difficult. Now let's see how long it takes to actually switch this over and get it ready to weld. So I have changed over my wire. I need to change a drive roll as well as the MIG gun over to that specially set up MIG gun. It has a graphite liner in it and a little bit thicker outside, but the whole process takes less than 5 minutes. So I'll tack up some 1/8 inch thick aluminum here with the MIG gun, and notice I'm using a little bit of a longer stick out here, and I always use a push angle. The shielding gas when I'm welding this is straight argon, and it's working out really well here. Notice I'm making a bit of a stitching motion back and forth. This can give a bit of a rippled appearance. It also just helps to be able to time progression. It's running in pretty well. As I get towards the end, the heat is building up a little bit in my coupon, and you can see the whole thing warming up. You could see that there really was no issue feeding that wire up through the gun. Everything ran nice and smooth. Now I just thought I'd show you, if I don't use that stitching motion and just run straight across, what that looks like, and it comes out fine as well. So that's an option. You don't have to move like that. The machine runs great either way. So I decided to turn it up and try it up at the higher end of the range here on some 1/4 inch thick material and see how that would work. Now ideally I would run this with a larger diameter wire, but since this was in the machine, I tried it out and it worked alright. So I got a pretty good result there. So I've switched over to run some pulsed MIG on this. And once again, this just helps limit your heat input. You can weld some thinner materials, and it's another tool to have in your tool belt. That's the nice thing about having all these different features here on the machine, is you just, whatever comes your way, you can have something that might help out. You don't always need it, but it's nice when you do. Something else that's pretty unique is they have it set up so that you can use one of these remote amperage controls as you MIG weld, because as you weld along, your heat gets built up in the material, so you often need it a little hotter. Watch my thumb, I'll pull it down just a little bit for the majority of the run, and then I can sit there as I weld. It's sort of in a steady state, but it's going to build up here towards the bottom, and I can just back that off manually here using that hand switch.
The area where most multi-process machines that I've used in the past really fall short is with TIG welding. It often feels like they're a MIG welder and they tacked on some TIG welding functionality afterwards to call it a multi-process. Well, they developed this one from the beginning to have the capability of a dedicated TIG machine. Let's take a look at how it works.
So I'm going to start off here with some DC TIG, and the arc is smooth and steady on this one. It reminds me a lot of their Invertig machines and a lot of the higher-end machines. I mean, with what you expect for this machine, you'd expect it to have a real nice DC arc, and it definitely lives up to that. So I ran a couple of these to try to get the shots here, and they came out typical steel lap joints, carbon steel there, so no surprises there at all. Now I've turned on the pulser at a high frequency to be able to run an outside corner joint here on some stainless steel. Now this is an autogenous joint without any filler metal on some 1/16 inch thick material. And this is a really good practical application. You can see the arc looks basically steady here, even though it is running that pulser, but that helps me to limit that heat input. And it's nice that on the machine here, you can actually have a lot of adjustability with the pulse settings. And so I was able to get a pretty good result there from that stainless steel, just that light straw color on it. Let me show you something else that I thought is pretty cool on this thing. So it not only has your start amps you can adjust, but also a hot start, which is a quick burst of amperage. Now a lot of manufacturers actually do that, but they don't all make it adjustable to where you can change it. So if you want to actually start at 5 amps, no kidding, on this machine you can do it. And that's going to be useful here because I'm going to try to redeem myself on this razor blade challenge. So I've just tacked a couple together here, and I have it sitting without any backing material this time. And notice I was able to start right up on there. If you see a lot of people doing this, they'll start over on their table off the side or on a piece of filler metal. But I was able to start right up on the corner there, and I can just push and trace the puddle along because I have that 5 to 15 amp range, and it comes out really smooth. And it actually made it pretty easy to be able to run this. It really wasn't any big deal for this machine. Now I wanted to try it on the top end of the range as well, so I got some 1/4 inch plate. Now this isn't how I'd actually weld it, and honestly these aren't the right consumables to use for it. It just makes it easier to film. And really, I'd rarely use 250 amps on DC. It's really on the AC side of things where that extra amperage is going to be helpful, but it still does work. It works really well. Again, this isn't how I'd weld it, but good test for today.
Let's switch over to AC now to TIG weld some aluminum.
This has all the adjustability that really you'd expect on any dedicated TIG welder when it comes to AC welding. You're able to change your frequency and balance, your regular settings, and you're also able to change between a couple different waveforms. We'll try that out in a minute. But everything runs nice and smooth. Really no issues there, exactly like you'd expect for a machine in this range. Here's a T-joint that I ran with it as well, and everything went in nice and smooth. I wanted to test this a little bit more, so I got some 1/16 inch thick aluminum, and I set this to the triangle wave setting, and I'm maintaining a puddle right on the corner of it and just running an edge weld to see if I can hold that puddle there on the end of the 1/16 inch thick material. And this is a good practice exercise, but it's also a pretty good machine test here. And it's able to do it. It's running nice and smooth. I mean, it looks bigger than it is, but that's a pretty small edge there. It probably wouldn't hurt me to run this exercise every now and again, but the machine was certainly capable of maintaining the puddle there on the edge. Now let's try it on the thick side with aluminum here, and so I've tacked up some 1/4 inch thick plate. And this is kind of dirty material. It's been in machining coolant and things, so I cleaned it the best I could, but it's still a little on the dirty side, so keep that in mind. But either way, the machine has no problem punching right through that 1/4 inch thick plate. That's one nice thing about having a 250 amp machine, is that extra 50 amps over the 200 amp ones really makes a difference when you need to weld that 1/4 inch.
While stick welding is certainly not as exciting as the MIG and TIG that we've done so far, it is really useful to have that capability. Let me show you what it can do.
I'm just going to run a simple T-joint here with a 1/8 inch 7018, and I have the machine set to 130 amps. Now it's running really smooth here, no surprises, no issues. You know, you'd expect a machine with all this capability to do fine with a stick rod. But one thing that it does have is a pulsed stick option. So if you do have a use for that, to be able to, you know, limit heat input or in a special circumstance, then that is available. This isn't using it. This is just your straight DC stick weld.
Now, this is a dual voltage machine, so it can run off 240 or 120 volts. So far, we've been using my 240 volt service. I'm going to switch it over to a regular 120 volt, 20 amp household circuit, and we'll take a look at that.
Now on the 120 volt outlet, it's able to run up to 110 amps on a stick rod, and that's really impressive. I actually have tried that out. Right here, I'm just running a 3/32 of an inch 7018, and it's set there at 90 amps, and it runs just as smoothly as it did on 240 volts, so there's really no issue there on the stick welding side of things. And I decided to change it up here for the MIG welding and to run some 1/8 butt joints here. And this is a good way to see, you know, can you get full penetration with 120 volts on 1/8 inch thick material, and you should be able to. And this is also a good exercise if you're learning to run open roots. Now I did run into an overcurrent alarm that's, you know, based on my particular situation. Perhaps I need to change a contact tip or something, but that's only with the machine absolutely maxed out. When I backed off a little bit, I was able to run it, and I tested this out, and I ran it for a long time with no issues at all, just by backing it off a little bit off of the maximum. Now I'm running this other joint right here. We'll complete that, and you can see it's burning in nicely and running smooth and steady. And honestly, the 120 volt performance and the 240 volt performance is basically identical from my perspective. I got a smooth bead on the front side and full penetration over on the back. So just what I was hoping for. Now on the TIG side of things, it's limited to 150 amps when you're running on 120 volts, and that's really pretty good. And so you can weld, you know, 1/8 inch thick aluminum, no problem. And I wanted to run this more than just one bead on plate here, so I ran several different beads just to test it and make sure it keeps up with that. And it really did no problem there, so I think that could be a really useful tool. The performance is basically identical from my perspective when you're going between 120 and 240 volts, other than your maximum amperage being limited, and that comes down to the laws of physics, really. So definitely good performance on the 120 volts.
I told you at the beginning of the video I'd let you know what I don't like about the machine, and there are a couple of things. It's heavy. It's still portable, there are 2 handles on it and you can carry it, so I wouldn't mind taking it with me occasionally, but I probably wouldn't want to hike up 6 flights of stairs with it every single day. Also, the fan never shuts off. Now, it's not like some fans that sound like a jet taking off, and it is fan on demand. So when you first plug it in and turn it on, it runs at a low speed. It sounds a lot like a desktop computer, and then it revs up to a higher speed when needed, and it's still relatively quiet compared to most machines that I've used. That being said, it never turns off. One other thing is that their remote amperage control can tend to slide around on the handle. I kind of wish there were a better out-of-the-box solution, but I actually put just a little sheet of rubber underneath mine and clamp it in place, and that seems to hold it good enough. Now beyond that, there really isn't much to roast about this one. I think they did a good job of putting together a solid all-in-one package. That being said, if you feel like you'd rather have two separate machines rather than an all-in-one, they also have their combination. You can get a Pro Pulse 220 and an Invertig 221 like I've been using for a while, and that can give you some pretty similar capability. So I'll put links in the description to all three of these machines. Thanks a ton for tuning in. If you enjoyed this or learned something, let me know by hitting that thumbs up below. We'll see you next time.